Imagine if you had a tool that could look at the past movements, cost of the stock, its prices, its trading volumes, and then give you a glimpse into where it might go next. Sounds futuristic, right? Well, thanks to artificial intelligence, it's already happening. So, hello everyone. My name is Priyanshi Priya, and today I am going to take you to behind the scenes of my latest project, an AI-powered stock price predictor built using Python, Google Colab, and a type of neural network called an LSTM. So now before I dive into the technical details, let me share why I chose this project. So like as an MBA student, I constantly thinking about how finance, technology, and tragedy intersects. The stock market has always fascinated me because it's such a dynamic, unpredictable system. And I wanted to explore how artificial intelligence, specifically deep learning, could be applied to stock forecasting and how the project was born. So basically, let's start. So the big question is, why AI? So the traditional stock analysis relies on methods like fundamental analysis, studying a company's earning, balance sheet, and industry positions. A technical analysis which looks at charts, moving averages, and price trends. In other words, instead of telling the computer if this happens, then that predicts. We let the algorithm discover the hidden patterns. So that's especially powerful for financial data, which is full of non-linear relationships and time dependencies. So the next step was the data collections. So using the the next step was the data collection. Using the finance library, I downloaded historical data for Apple stock from January 2020 until today. Of course, this model can be applied to any stock tickers, but I chose Apple as a case study because it's widely followed, liquid, and has enough data to train on. Why price and volume? Because price tells us the direct value of the stock, while volume reflects the intensity of trading activity. When both are combined, they often reveal more than either one alone. For example, a price increases with high volume is generally more significant than a price increase on low volume. So now next is data preparations. Once I had the data, I needed to prepare it for the model. First, I scale the values using min-max scalars, which normalize data between 0 and 1. Neural networks works best when the inputs are with a consistent range. Then I created sequence of 60 days each. In other words, the model looks at the past 60 days of the price and volume, and based on that, it tries to predict the next data closing price. So by end of this step, I had two sets. X trains the input sequence of 60 days of data, Y trains the output, which is the stock price of the 61 days. So now building the model. Now for the heart of the project, the model itself. I built a sequential LSTM model in Keras. Here's the architecture. The first LSTM layer had 50 units and return sequences, so it could pass data to the next layer. A dropout layer was added with a 20% rate to prevent overfitting. A second LSTM layer with 50 units proceeds the sequence. Another dropout layer was added. Then came dense layer, first with 25 units and finally an output layer with 1 unit, representing the predicted price. I compiled the model using the Adam optimizer and mean squared error as the loss function. To train the model, I used a batch size of 32 and ran it for 100 epochs. This training step is where the model learns pattern, adjusting its internal weights through backpropagation. So now the step came was the testing the model. After training it, was time to put the model to the test. It set aside about 20% of the dataset as test data the model had never seen before. This is important for evaluating real performance. The test data was scaled, divided into sequences, and fed into the trained LSTM. The model then generated predictions for Apple future prices. The results were compared against actual values, and I calculated error metrics like mean squared error (MSE). I also visualized the prediction versus real price using Plotly, which made it easier to see how well the model was tracking the trends. So the next step was the results and the insight. So what were the results? The model was able to capture general trends quite well. It could follow the overall upwards or downward movement of Apple stock with reasonable accuracy. For example, in period of consistent growth or decline, the prediction closely mirrored reality. Of course, during sudden spikes or drops caused by new events, the model struggled, as expected, because it was only trained on past price volumes, not external factors. This leads to an important insight. AI can enhance decision making, but it cannot replace human judgments. Investors still need to consider news, global events, and company fundamentals. That said, having a tool like this can give trader a statistical edge, especially for short-term forecasting. So now, as exciting as the project was, it wasn't without challenges. Data limitation, stock market are influenced by countless variables from earning reports to geopolitics. My model only used price and volume, which limits its predictive power. Overfitting, neural networks can sometimes memorize the training data instead of generalizing. I used dropout layers to combat this, but it was always risky. So where do I go from here? I see three existing path forwards, adding more features instead of just price and volume. I want to add indicators like moving averages, RSI, or even sentiment analysis from news headlines and social medias. Developing the model, eventually I would love to create a simple web app or mobile dashboard where anyone could enter the stock tickers and see AI generated forecast in real time. These steps would make the model more robust, user-friendly, and practical. So now, to wrap things up, this project was an exciting journey into the world of AI-driven stock predictions. Using historical price and volume data, I built an LSTM model that could forecast stock movement with reasonable accuracy. While it's far from perfect, it proved that AI has real potential to enhance decision making in finance. Still, I would love to hear your thoughts how you would improve this model. Should I add sentimental analysis or maybe try out a transformer model? Let me know in the comment below. If you found this video interesting, don't forget to hit the like button, subscribe